I mentioned AP firmware in the last video. It's the main firmware for your device, responsible for loading the OS. But what does it actually contain? Well, it depends. There are a lot of things it might contain. Here I'm going to cover some of the common bits. So broadly speaking, we can divide the main firmware into two pieces. Platform init, responsible for initializing the hardware, and the bootloader, responsible for loading the OS. In practice, sometimes these are combined. So let's look at platform initialization first. The silicon vendor likely has some pieces in platform init for setting up the silicon. On Intel chips, this is called the Firmware Support Package, or FSP. This sets up the memory controller so that memory works, and then everything else. Everything else includes things like USB, storage, graphics, and so on. On AMD chips, there's something similar, but it's called AMD Generic Encapsulated Software Architecture, AGESA. For ARM chips, there is something called Trusted Firmware A, and that does some very basic initialization of the CPU cores and may in fact also initialize memory. The device vendor likely has some code in there in the platform init to set up things like the display or the keyboard. Other things in there may be a vendor logo, a setup screen, or perhaps some firmware that's needed for the system to boot, such as the security firmware. So that's platform init. Let's move to the bootloader. As I said, it's responsible for loading the OS. So it goes out and scans for available storage devices, looking for operating systems in each one, and then selects one to boot and boots it. Typically it'll select this automatically, but the user may have some control depending on the device. For example, to decide to boot from a USB stick instead of the internal storage. For Windows computers, the platform init and bootloader are combined into a single program called Unified Extensible Firmware Interface, or UEFI. UEFI provides a plug-in style architecture, so the silicon vendor, the device vendor, and anyone else who feels like it can add code into the firmware fairly easily. So the code from the FSP, AGESA, and anything the device vendor provides are all mixed into that UEFI firmware. For ARM devices, U-boot is often used. This doesn't have a plug-in architecture, so each device vendor must build in the code that's required, drivers and so on, for the different pieces of hardware in their device. The AP firmware is typically 8 to 32 megabytes. Now that doesn't sound like a lot in these days of 5 megabyte JPEG photos and so on, but you can actually fit quite a lot of code in that much space. One more point I should make. Everything I've described here is a bit of a generalization. Every device may be different and have different arrangement of the code. If you're really interested in seeing what's in the firmware for a particular device, I encourage you to have a look out on the internet, and you'll find tools for listing it and decomposing it and seeing what's actually in the firmware.